system. Then how do you calculate the angular moment of the system? In the given case, when you consider, so at this point, okay, so this is the position we can consider. We have tangential speed followed by, okay, center of mass. So therefore, we have the resultant speed, okay, here we have resultant speed of V3. Similarly, here and here we have resultant speeds we have. That means, so this is V1, V2 and V3 are the resultant speeds at that particular cases. And try to find out the perpendicular component to the position vector. Now the radius is R1, radius is R2, radius is R3. Note that is, we know that angular momentum is equal to greater as mvr. In the given problem, as the value of R is large, okay, for P3 position, therefore angular momentum here is more compared to remaining 2 points. That means angular momentum L value at P1, which is less than compared to L at P2, less than what? L at P3, we can write out for this particular case. Thank you. Now, let us see the concept. In the given problem, let us try to imagine that there is some object which is allowed to rolling because of the external force of F at a height of h from the ground. Then, by applying the angular momentum, what is the formula for angular momentum? L is equal to mvr. R is nothing but what here? Radius of rotation. Radius of rotation is nothing but what? This is the applied force. And this remaining part only we have to take into account. Remaining part, remember. So therefore, the remaining part is how much? H minus R. That is the radius we have to take with respect to center. Now, according to the actual formula, it is equal to I into omega. Omega is nothing but V by capital R. And I is nothing but mk square. Because of radius of gyration of the system is nothing but k. And upon solving, we got the value of h is equal to, you can write down as R of 1 plus k square by r square. Now, if the value of h is exactly matching with this particular parameter, take k square by r square as 1, k square by r square as nothing but, depending on the moment of inertia, k square by r square value will be different. So therefore, we will try to substitute the value of k square by r square. If it is balanced, then there is no frictional force. Simply, you can take it as what? Frictional force as F is equal to 0 in the problem. But on the other hand, now in this particular case, if this entire calculation is found, but our height where we are force applying, okay, is greater than. So in such a condition, frictional forces acts in the forward direction. If the h value is less than this particular value, expected value, then frictional forces are action in what direction? Backward direction. In such a condition, remember exactly opposite direction here, backward slip, and here forward slips are exist. So how to determine